This section is about the hydrocarbons. In section 1, we have identified the hydrocarbons, and we said the hydrocarbons are simplest form of the organic molecules which only compose of the hydrogen and carbon. So that's why their names are hydrocarbons. So they are the simplest form of the organic molecule that we have. It only contains two elements, carbon and hydrogen. We have three main group of the hydrocarbon, depends on the bond which are available between the carbon and carbon. So we want to talk about the hydrocarbons, which is the simplest group of the organic molecule. They only have the carbon and the hydrogen in their structure. The hydrocarbons can be divided into two main groups. One of them we call it saturated hydrocarbon and unsaturated hydrocarbon. The unsaturated hydrocarbon is divided into two groups, but the saturated, it has only one group. The saturated hydrocarbon are called alkane. You have A and E at the end of the name. Okay, this suffix is very important. And the alkanes are the hydrocarbons which you have only carbon-carbon single bond. So you have carbon, single bond, carbon. Okay, so you have only single bond between the carbons, called the alkane. Unsaturated hydrocarbons, they have two groups. One of them we call it alkene, E and E at the end. The other one we call them alkyne, Y and E at the end. Okay, so again, these suffixes are very important. So you have alkane, which there is only carbon-carbon single bond. Alkene, you have at least one carbon double bond carbon. Okay. And for the alkyne, you have at least one carbon triple bond carbon. So these two groups are called unsaturated, alkene and alkyne. This one which you have only single bond, we call it saturated. For example, I draw one alkane molecule. This can be a simple alkane molecule. First, it is hydrocarbon because the carbons are bonded to each other. And you have only a single bond between the carbons. So this is an alkane. A-N-E at the end. Look at this one. Suppose you have carbon, single bond, carbon, double bond, carbon, single bond, carbon. You have hydrogen, hydrogen, hydrogen. Okay, for this carbon, how many hydrogen I have to put?
One.
One, yeah. You can see it has 1, 2, 3 shared of electrons. So one remains for that one because carbon has 4 valence electrons. So the fourth one only can share one bond with the hydrogen. Same thing happens for this carbon. Okay, it has 3 shared electrons, so one remains for itself. And for the last carbon, it has 1, so it needs 2, 3, 4. So this is an example of alkene, E and E at the end, because you have at least one double bond there, and this is called unsaturated. And this one, C, triple bond, carbon, single bond, carbon. Okay, so tell me how many carbon I must put for this one? How many hydrogen?
3 hydrogen.
Yeah, I need 3 hydrogen. It has 1, 2, 3, 4 hydrogen. What about this carbon at the middle? How many hydrogen it needs?
It doesn't need any because it already has 4 bonds.
Yeah, it doesn't need hydrogen because all of its 4 electrons are participating in the chemical bond. okay, in the covalent bonding. So it doesn't need any hydrogen, but the first one, this one, it has one triple bond, so it needs only one hydrogen here. Okay, this is an example of alkyne, YN. Okay, so this one is saturated, and these two are unsaturated hydrocarbon. This one is very important because it makes the base for the naming rest of the hydrocarbons. Let's go back to your book. The definition of saturated hydrocarbon is given here. The saturated hydrocarbons are hydrocarbons in which each carbon atom in molecule forms 4 single covalent bonds with the other atoms. The hydrocarbons that contain only single bonds are called alkane. So let's talk about the alkane a little bit in more detail. Okay. So here I write its chemical formula or that structural formula. Okay. So I draw the uncondensed and condensed format. Then I will write the molecular formula here. Okay. And here I write the name of that. The first alkane has only one carbon. So it has one carbon, the first member of the alkane group. So how many hydrogen I have to put for this carbon?
4.
Yeah, I need to put 4 hydrogen. This is uncondensed structural formula. If I want to write the condensed format, I don't show the bond between the carbon and hydrogen. I just write how many hydrogen do I have. So I have 1 carbon with 4 hydrogens, CH4. Okay. So the molecular formula, which shows the type of the atom and the number of each one of them, you have 1 carbon and 4 hydrogen. So the molecular formula is also CH4. The name of this one is methane. Okay, METH and ANE because it's alkane. So this one is methane. Let's go to the next member of this group. The next member of this group has carbon-carbon bond. It has 2 carbons, and because it's alkane, the bond between the carbons are single bond. Now, how many hydrogen I have to put for each carbon?
3 hydrogens for each.
Exactly. Each one of them needs 3 hydrogen to become octet. This is uncondensed structural formula. The condensed structural formula, the carbon which is at the left is CH3. It's bound to another carbon with it also has CH3. Okay. So what would be the molecular formula for that?
C2H6.
Exactly. I have 2 carbon, 6 hydrogen. The molecular formula for that is C2H6. This member is called ethane. ETH and ANE because it's alkane. Let's go to the third member in this group. The third member has 3 carbons. 1, 2, 3. As you can guess, the carbon which are at the beginning and end of the chain, they need 3 hydrogens. The carbon which is at the middle, it has already 2 bonds, so it needs 2 more bonds with the hydrogen. And the first carbon needs 3 bonds. This is the uncondensed structural formula. Condensed structural formula would be CH3 for the first one. Second one is CH2. And the last carbon here is also CH3. So it's CH3, CH2, CH3. And what would be its molecular formula?
C3H8.
Exactly, C3H8. You have 3 carbons here in this structure and 8 hydrogen. This carbon, hydrocarbon, is called propane. Okay, and A and E. So this is propane. The next hydrocarbon has 4 in this group. Has 4 carbon. 1, 2, 3, 4. The first carbon needs 3 hydrogen. The second carbon needs 2 hydrogen. The next one needs 2 hydrogen. The next one needs 3 hydrogen. The condensed formula for that one, the first carbon is CH3. Then you have CH2. Then you have another CH2. And the last you have CH3. So the molecular formula for this one is C4H10. If you count the hydrogen, there are 10 hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the carbons 1, 2, 3, 4. So the molecular formula is C4H10. This one is called butane or butane. A-N-E. This is the 4th member of the alkane hydrocarbon. Okay, the next one, it has 5 carbons. So I don't draw the uncondensed structure formula. I just draw the condensed structure formula. It is CH3 bonds to CH2, bonds to another CH2, bonds to another CH2, bonds to another CH3. So you can see that I have 5 carbon here. The molecular formula would be C5, and if you count the hydrogen, there are 12 hydrogens here. Before going for the naming this one, I want to draw the next one as well with the 6 carbon, CH3, CH2, CH2. You can put this bond between the carbon or you can miss that one. CH2, CH2, so up to now I have 4 carbons. This is the 5, and the last one, it must contain 3 hydrogens. Okay, it's CH3. So the molecular formula would be C6H14. Okay, what is the name of them?
The first 4 members of the alkane have generic name, but the rest of them, their name comes from the Greek numbers penta, hexa, hepta, and so on. So the alkane with 5 carbon must be pentane. It comes from penta, but we drop the A and we put A and E at the end. The member with 6 carbon becomes heptane, and so on.
So what would be the name of the next hydrocarbon with the 7 carbons? 7 is hepta, so this one becomes heptane, exactly. Okay. So what would be the formula for heptane? It would have 7 carbon and the number of the hydrogen would be 16. So if I want to draw its structure, it becomes CH2, 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 1, 2, 3, 4, 5, 6, 7. So this is heptane. So the next one, what would be the next one?
Octane.
The next one, yeah, octane. Comes from octa. So it becomes octane. So the first 4 member has the generic name ethane, propane, butane, pentane. Sorry, methane, ethane, propane, butane. This has generic name. Methane has 1 carbon, ethane has 2 carbons, propane has 3 carbons, butane has 4 carbons. But for the rest of them, we use the Greek number pentane, hexane, heptane, and octane. Here you can see that the length of the hydrocarbon chain becomes very long. So instead of writing all of this CH2, I can write it like this. I can write CH3 in the parentheses, CH2. How many CH2 do I have here? 1, 2, 3, 4, 5. 5, and then finally I have CH3. So this is another format to show the long chain hydrocarbon that we have here. Okay, so I want you to compare the formula which are available for the hydrocarbons. What is the difference between them? What is the difference between these ones?
So every time one carbon is being increased and then 2 hydrogen.
Exactly. So by increasing the number of the carbon in the molecular formula, a CH2 is being increased, that one. So 1 carbon, 2 hydrogen, it becomes C2H6. For the next one, 1 carbon is added, 2 hydrogen. So another CH2 is added here. So the next one is also another CH2 is added here. So the group of or members of the same group of any organic compound, the difference between them is only 1 or more than 1 CH2. So for example, the difference between the methane and propane is 2 CH2. The difference between the ethane and propane is 1 CH2. We call this homologous series. So we can say alkane homologous series. So the homologous series are just another name for a specific group of the organic molecule. So this group of the organic molecules are alkane. So the scientific name for that is they are alkane homologous series. So the member of the homologous series, the difference between them is only 1 or more CH2. That's all. Nothing else changed for the membrane of the same homologous series. So compare the ethane and propane. So what the propane has more than ethane? It has 1 CH2 group. That's all. If it has 2 more CH2 group than ethane, it becomes butane. Okay. So it says the compounds that differ in this fashion belongs to a homologous series. So the homologous series is just another name for the specific group of the organic molecule. Okay, so let's go back to here. So look at the chemical formulas that we have here. Okay, CH4, then C2H6, then C3H8, then C4H5, then C5H12. Can you find any relationship between the number of the carbon that we have here and the number of the hydrogen? Is there any relationship? For example, the relationship between these 3 carbons and the 8 hydrogen, the relationship between 4 carbon and these 10 hydrogen. Who knows what is the relationship between them?
Like, you can times it by 3, but for propane you can't. So maybe if you times it by 2, and then it'll be 4, and then plus 2, and then 3 times 2 will be 6, and then plus 2 will be 8, and then 4 times 2 will be 8, and then plus 2 will be 10.
Plus 2 will be 10. Exactly. So we have a relationship between them. Okay. If the carbon is N, so if you have N carbon, the hydrogen would be twice as the number of carbon, 2N plus 2. Okay. So if you have only 1 carbon, like here, the N would be 1. So then 2 times 1 plus 2 becomes 4. If you have 2 carbon, the N is 2. Then 2 times 2 plus 2 becomes 6. Okay. If you have 3 carbons, 3 times 2 becomes 6 plus 2 becomes 8. So this is called general formula for alkane. So for the alkane, I can write the general molecular formula. If you have n carbon, the number of hydrogen would be twice as the number of carbon plus 2. So who can tell me what is the formula for the alkane which has 20 carbons?
C20H42.
Exactly. So if the carbon is 20, if you have the alkane, a member which has 20 carbon, the number of the hydrogen in that member is 2 times 20, 40, plus 2 becomes 42. So if they give you a molecular formula, you must be able to determine if that one is alkane or not. Okay? For example, which one of these is alkane?
C12H26.
C12H26, because if the carbon is 12, if you multiply it by 2 and then add it 2, it becomes 26. So it means this one follows the general formula of the alkane, CnH2n plus 2. But this one, if you multiply it by 2, it becomes 22. If you add it 2, it must becomes 24. So it means what is written here, C11H22, is not an alkane. Okay, so very good. Let's go back to your book. Okay, the general formula for alkane is written here, C2H2n plus 2. So if you know the number of the carbon, you can guess how many hydrogen would be there. Okay, so if you have, for example, 30 carbons, the number of hydrogen must be 62. It means if the number of the hydrogen is twice as the number of carbon plus 2, you have alkane. Okay, so this table shows the molecular formula and structural formula and space filling model of the alkane. So the first one is CH4, methane, C2H6 is ethane, C3H8 is propane. But look at the C4H10. If you remember, we said we can have different arrangement of the atoms. So it can be like this: 1, 2, 3, 4 carbons consecutively makes a long chain of the hydrocarbon. We call it butane. But exactly, we can have the same molecular formula but different structure. In this structure, you have 1, 2, 3, 4 carbons and 10 hydrogens. But these two, if you remember, we said they are isomers of each other. So if the name of this one is butane, what is the name of these isomers? The name of these isomers must obviously be different from this one, because these two are two separate molecules with their specific properties which is different from each other. So the very important topic in the organic chemistry is the naming of the hydrocarbons. What I have shown you here with the names is for a straight chain hydrocarbon. So straight chain hydrocarbon is the hydrocarbons which carbons are connected to each other consecutively. So here you have one carbon is methane, two carbons are joined to each other, it's ethane, three carbons joined to each other is propane, four carbons joined to each other is butane, five carbons are joined to each other, it is pentane. 6 carbons are joined to each other, it's hexane. 7 carbons consecutively joined to each other and it forms a long chain of the hydrocarbon is heptane, and so on. Okay, so these names which you have here is for straight chain hydrocarbons. But what if we don't have the straight chain hydrocarbon? That's what we can see here. Okay, so in this type we say we have branched hydrocarbons. This is the chain of the hydrocarbon. It has one branch here. So these are called branched hydrocarbons. We want to talk and we want to study the naming of these branched hydrocarbons. For the straight chain hydrocarbon, the name are as we have mentioned earlier. So we want to talk about the naming of the alkane when we have branch. Okay. So for the butane, we start from the butane, C4H. What should be the H?
10.
10. Okay, 4 times 2 plus 2 becomes 10. So for the butane, you can have 4 carbons which are connected to each other in the straight chain, or you can have 3 carbons and 1 carbon is connected here. Okay, so if I want to put the hydrogens here, it needs 3 hydrogens. Here it needs 2 hydrogen. Here it needs 2 hydrogen. Here it needs 3 hydrogen. And for this one, you need 3 hydrogen here, 1 hydrogen for this carbon, 3 hydrogens for this carbon, and 3 hydrogens for this one. Okay, so both of them are C4H10. So when you want to name an organic molecule, especially the alkane, you have to find the longest chain. The longest chain are the longest path of the carbons which are connected to each other. For example, for the first one, the longest chain of the hydrocarbon starts from here up to here. So this is the longest chain. It's straight. It doesn't have any carbon connected to this chain. So this is just straight chain hydrocarbon. And when we have 4 carbon, it is butane. But for the next one, we have to find the longest chain of the hydrocarbon. Okay, so if I start from this carbon here, this is carbon 1, 2, 3. It can be the longest chain which I can find in this structure. So I take the longest chain and we call it the parent chain. So this one is parent chain. So the parent chain is the longest chain of the hydrocarbon. So what about this carbon that we have here? This carbon is called branch. So a branch is connected to 3 carbon parent chain. What is the branch here? The branch here is CH3. Let me write the condensed format of this molecule. It is CH3, it's connected to the CH, connected to the CH3, and it's connected to the CH3 here. Okay, so this is the straight chain or the parent chain, and this is the branch. So the branch here is CH3. So it means the carbon which has 3 hydrogens, and it's connected from this part to the parent. So what was the name of the alkane which had 1 carbon?
Methane.
Yeah, it was methane. When it is the branch, the methane changed to methyl. Okay, so we save the first part, so it becomes meth, and we add YL, methyl. So A and E converts to YL. So methane becomes methyl. So the name of this branch is methyl. That's why these branches are called alkyl. Okay, so we had alkane, just the A and E is replaced by YL. So if the branch is like this, C, H, 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 and it connects from here to the parent chain, what would be the name of this one?
Ethyl.
Exactly. If you have 2 carbons, the alkane would be ethane. So here it becomes ethyl. And if you have 3 carbon as a branch, what would be the name?
Propyl.
Propyl, exactly. So if these 3 carbons are joined to the main chain or parent chain from here, it would be propyl. Okay, you must memorize them. Okay, so if you have CH3 As a branch, it is methyl. If you have CH2, CH3, sometimes we can show it by C2H5. Okay, it is ethyl. If you have CH2, CH2, CH3 as a branch, or we can write it C3H7, it's called propyl. So these are called branch.
So, sir, the alkyl have one less hydrogen than alkane.
Exactly.
If
Alkyl
we
has
go with the
one less
formula, for
hydrogen than
example.
alkane. Okay, that's why it can join to the main branch from that part. Okay, so they have one less hydrogen than alkane. So these are the alkyl branch. So we call them alkyl branch. Okay, so you have butyl, propyl, and so on, but they are less common. So the most important one are these three ones. Okay, methyl, ethyl, propyl, we call them alkyl branch. Sometimes instead of the hydrogen, halogen is connected to the main branch or the parent branch. So for example, the fluorine can be connected there. Sometimes the chlorine can be connected to the main branch. Sometimes bromine and iodine. They also has a special name if they are appears as a branch. If the fluorine is connected to the parent chain, it is called fluoro. If the chlorine is connected, that is called chloro. Bromine is called bromo, and iodine is called iodo. Okay, so there are name of the branch. You must memorize these ones: methyl, ethyl, propyl, fluoro, chloro, bromo, and iodo. Okay, so how we can use them? Let's go back to our examples that we had here. Okay, this one. So when you want to name any hydrocarbon, the first step is to determine what is the longest chain. The next, you have to determine what are the branch. So what is the branch here? The branch is CH3, so the branch is methyl.
Methyl.
First, you have to name the branch. You have to write it. So I have methyl. And what is the hydrocarbon? What is the alkane which has 3 carbon?
Propane.
Propane. So this one is methyl propane. So what you do when you want to name the alkane which has the branch, at the beginning you write the name of the branch, and then you write the name of the parent chain. The parent chain has 3 carbons, so it's propane, and the branch is methyl. Okay, let's do another example. Suppose you have these compounds, CH3, CH2, CH2, or let it be CH, it connects to CH3, it's connected to CH2 and CH3. Okay, so I want to name this hydrocarbon. What should I do? The first step, I have to find the longest hydrocarbon chain. So tell me how many carbons are in the parent chain or in the longest hydrocarbon chain? How many carbons are there?
6. 5.
5 or 6?
I think 5.
Okay, so look, you can consider this one as a parent. 1,
Because
2,
if you go
3.
straight, then it's 4. But then if you come down,
Okay, so you can come down also. 1, 2, 3, 4, 5. Okay, you have to choose the one which has the more number of the carbon. So the one which is longer. So the red one is not the parent chain. The parent chain is actually this one. Okay, so as I said, no matter if the carbon is written straight or it's bent. Okay, so no matter how it's written, what is important, they must be consecutively, they must be connected to each other. So this blue one has 5 carbons. So this is the parent chain. So what would be the name of the parent?
Pentane.
Pentane, yeah, the parent is pentane. Okay, and what is the branch? CH3 is
Methyl.
methyl. Okay, so the name of this one is methyl pentane. Methyl pentane. Okay, so let's draw another example here. So I will draw the same, almost same molecule, CH3, CH2, CH2, CH.
Sorry, sir, I have a question. In the previous one that we did right now,
Yeah, we will come back to that. Yeah, we will come back to that.
Okay.
Okay, so look at this one. Again, if you want to find the longest hydrocarbon chain, you can go from here 2, 3, 4, 5. Okay, and you can go like this 1, 2, 3, 4, 5. So both of them has 5 carbons. So no matter which one you choose, both of them are exactly the same. Okay, so I prefer to choose this one which has less bent inside the molecule, this one. Okay, so how many carbon are there in the parent? 5. So the parent is pentane as well. And what is the name of the branch? CH3 is
Methyl.
methyl. So this one is also methyl pentane. But there are 2 different molecules, so we are not allowed to name 2 different molecules with the same name. Okay? So that's why, in this case, the only difference between these 2 molecules is the position of the branch. Okay? For the first one, the CH3, the methyl is connected to this carbon. For the second one, the methyl is connected to this carbon. So we have to also mention the position of the branch. Where is the branch connected to the parent? For determining the position of the branch, you have to number the parent. Okay, so let's start with the second one. I want to number the carbons there. I can number it in the 2 ways. I can number it from the left side. So this would be carbon number 1. This would be carbon number 2. This would be carbon number 3. This would be carbon number 4. And this would be carbon number 5. Or I can number it from the bottom. This is carbon number 1, then it becomes carbon number 2. This one becomes carbon number 3. This one becomes carbon number 4. This one becomes carbon number 5. Okay, so if the blue one is the correct system of the numbering, the branch is connected to carbon number 4. But if I choose the red one as the numbering of the parent, the branch is connected to the carbon number 2. We have to choose the numbering system which the branch receives a smaller number. So in this case, if I number the parent branch from the bottom, the parent chain from the bottom, branch receives number 2. So the red one is correct system of the numbering for this case, and the blue one is not correct. Because if I number it in the blue format, the branches would be connected to carbon number 4. But if I number it in the red format, it's connected to the carbon number 2. So I choose the red one, and here in front of the name of the branch, I also mentioned the position of that one. It is 2, and between the number and the letter, I have to put the hyphen or dash. So 2-methyl pentane is the correct name for this one. Now let's us determine the position of the methyl, the branch in this one. If I number it from the left side, it becomes 1, 2, 3, 4, 5. So the branch is on carbon number 3. If I number it from the bottom, it is number 1, 2, 3, 4, 5. In this case, also the branch is connected to the carbon number 3. So in this case, no different from which side I number the parent chain. In both situations, the branch is connected to the carbon number 3. So this one is 3-methylpentane. Any question here? So when you want to name an alkane, you have to determine the longest chain, you have to determine the branches, you have to number the parent or longest chain in a way that your branches receives a smaller number. Then you first name the branch and then name the parent. Let's go back to your book to solve one example in your book. Come to page, this one, 685. So here, a molecule is given. This molecule is alkane. How do you know it is alkane from the structure? Why, for example, it's not alkene or alkyne? This is alkane because only you have carbon and hydrogen, and all of the bonds between the carbon and carbon are single bonds. So this represents a member from the alkane. It's not a straight chain alkane, so it has the branch. For naming of that, the first step, we have to determine the longest chain. Okay? So I can choose the longest chain as this one. So I can go from here, 1, 2, 3, 4, 5. I can go farther, say 1, 2, 3, 4, 5, 6. Still, I can find the longer chain here. 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this one is the longest chain which I can find. Also, I can have this one as the longest chain. 1, 2, 3, 4, 5, 6, 7, 8. This one has 8 hydrocarbon as well. This one also I can choose as the parent. 1, 2, 3, 4, 5, 6, 7, 8. The blue one and the green one is almost same. Okay, so they are exactly the same actually. So both of them to this carbon, CH3 is connected. So this one is same. The blue one and the green one are exactly the same. So I only choose between these two. So which one I have to choose as a parent? Both of them has 8 hydrocarbons. So which one I have to choose as a parent? Okay, so let's consider each one of them. At the beginning, let's, for example, the red one be the parent. If the red one is parent, what are the branches? CH3, which is methyl, CH3, which is methyl, and one other branches is CH3, but itself it has branch. Okay, so this is not correct system for the numbering. When you want to find the longest chain, the branches must not have the branch themselves. So I'm not allowed to choose this red one as the parent, although it has 8 carbon and it's pretty long. Okay, so now let's go to the other side and choose this one as a parent. 1, 2, 3, 4, 5, 6, 7, 8. So this is my parent, it has 8 carbon. What are my branches? I have one methyl here, another methyl here. I have C2CH3 here. What is the name of C2CH3?
Ethyl.
Yeah, exactly, it's ethyl. And I have one more methyl here. Okay, so none of these branch has the branch themselves. Okay, so up to now, we determine correctly what is the parent and what are the branches. So now I have to number the parent. Let's say I number it from the left side. It becomes 1, 2, 3, 4, 5, 6, 7, 8. So what are the position of the branches? The first methyl is in position 4. The second one in position 5. This ethyl is in position 6. And this methyl is in position 7. Now let me number it from the bottom. This is carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, 6, 7, 8. So where are the location of the branches? The first one is at the second position. The ethyl is at the third position. And these two methyls are the fourth and fifth position. 4 and 5th position. You have to look at the first one. Which one I have to choose as a system of the numbering? The red one. Why?
2.
Yeah, because the 2 is smaller than 4. Okay, if they were equal, you have to look at the next one. Next one also, the 3 is smaller than 5. But we don't need to look at the rest of them because the first one, the 2 is smaller than 4. So the correct system of the numbering is the red one, not the blue one. Okay, so I have determined the parent ion, and I also determined from which side I have to number the parent. From the bottom I have to number it. It's carbon number 1, 2, 3, 4, 5, 6, 7, 8. Now I want to name it. So let's write the name of the parent. What is the name of the parent with 8 carbon? The name of the parent with 8 carbon is? Exactly, it's octane.
Octane.
A-N-E. Okay,
Octane.
I have the branches. What are my branches? One of them is ethyl. 3 of them is methyl. So I have 2 types of the branches. I have 3 methyl, 1 is ethyl. I have to name them in front of the parent. But which one I should mention it first? It's based on the alphabet priority. In the ethyl, we have E at the beginning. In the methyl, we have M. So which one has the priority alphabetically? Ethyl. E comes before M. So first, here I have to write ethyl. What is the position of the ethyl? Third position. So I write 3 ethyl. Okay. And then what are the position for the methyl? 2, 4, 5. I have to mention all of them. So I have in second position, fourth position, and fifth position. What do I have in those positions? In all of those positions, I have methyl. How many methyls are there?
3
Three methyls. So I have to also mention the number of them. So I write trimethyl. So this is the name of these most complex hydrocarbon which you have in your book. Okay, so this one is given as an example because all of the rules are applied for naming of that one. So let's review one more time. So at the beginning, you must find what is the parent. So you have to find the longest chain. But when you find the longest chain, the branches must not have the branch. So this one is the longest chain, and you have the branch. 2 types of the branch you have there. One of them is methyl, these ones. And this one is ethyl. So you have to mention them in front of the parent's name, but you have to number the parent in a way that these branches receive a smaller number. So this is number 1, this is number 2, 3, 4, 5, 6, 7, 8. When you want to name the branch, you start with the branch which has priority alphabetical priority. The ethyl comes first, its position is in the third position. So I write 3-ethyl. And then I have 3 methyls. So I write trimethyl. I don't write 2-methyl, 4-methyl, 5-methyl. I just write their positions, 2, 4, 5. And then I write how many of that branch do I have, trimethyl. If I had 2-methyl, I must write dimethyl. So these are most common, dimethyl and trimethyl. Okay, if you have 4, it becomes tetramethyl.
Sir, I had a question.
Yes.
For example, if we had octane with only, like in position 2, we had 2 methyl groups and nothing else, then would it be 2,2-dimethyl?
Exactly, 2,2-dimethyl.
So we have to repeat 2?
Yeah, you have to repeat 2 because both of them are in the second position. If you just write 2-methyl or 2-dimethyl, we don't know, we know one of them is in the second position, but where is the position of the second one? Okay, so you have to repeat that one. We will have the example. Okay, so let's do some examples to be more clear. Okay, so here also in your book, it explains how you have to name them. Okay, so here, the step-by-step is mentioned you how you have to name them. So if you have 2 identical group, you say di. If you have 3 identical group, tri. 4 identical group, you use tetra. Okay, and you know how to position. Okay, look, let's answer this one. So the first step, we have to find the longest chain. So the longest chain is this one: 1, 2, 3, 4, 5, 6. Also, you can choose this one as the longest chain: 1, 2, 3, 4, 5, 6. Both of them are same. Look at this carbon. CH3 group is connected. CH3 group is connected here. Look at this carbon. CH3 group is connected here. CH3 group is connected here. So both of them are exactly the same and both of them are correct. But I personally prefer to choose the one which is straight. So I prefer to choose this one as the parent because it has the longest chain and it is straight. Okay. I have branches, 1, 2, 3 branches. Okay, what is the name of my branches? Methyl. All of them are exactly the same. I have to number the parent. From which side I have to number it? Let's number it from both sides and let's see what happens in each case. If I number it from the left side, it becomes carbon number 1, carbon number 2, carbon number 3, carbon number 4, carbon number 5, and carbon number 6. If I number it from the right side, this is carbon number 1, this is carbon number 2, this is carbon number 3, this is carbon number 4, this is carbon number 5, and this one is carbon number 6. So where are the location of the branches based on these systems of the numbering? For the blue one of the branches are on carbon number 2, one of them is on carbon number 4, and the third one is on carbon number 5. But if I choose the red one, the first one is on carbon number 2, the second one is on carbon number 3, and the third one is on carbon number 5. So which one I have to choose? This one. The first branches is same for both of them, but for the second branch, the red one is in number 3, the blue one is in number 4. So the red one is correct system of the numbering. So I numbered my parent, so I'm now ready to name that one. So I have 3 branches, all of them are methyl. So first I have to mention the location of them. So it's in the second, third, and fifth position. So hyphen, I have 3 methyl groups, so I have to write tri-methyl. And what is the name of the parent? With 6 carbon?
Hexane.
The parent with 6 carbon is hexane.
Hexane.
Yeah. So this is the correct name for these hydrocarbons. Okay, so let's move on and let's answer these practice questions. Okay, for the first one, so obviously the longest chain is this one. It has 4 carbons. And what is your branch?
Methyl.
Branch is methyl. From which side I have to number?
From left.
From the
to
left,
right.
yeah. Because if I number it from the left, 1, 2, 3, 4, the branch would be on the second position. But if I number it from the right, it becomes 1, 2, 3, 4. It would be in the third position, which is wrong. Okay, so what is the name? What do you have on second position?
2-methyl butane.
Exactly, 2-methyl, and the parent has 4 carbons, so it is butane. For the next one, you have CH3, CH2, CH, CH3, CH2, CH3. So first we have to find the parent. The parent is the longest chain. This one is the longest parent. Okay, be careful about this one. This one has one more rule that I have to mention to you. It has 2 branches. One of them is methyl. The other one is ethyl. Let's number it from the both sides. If I number it from the left, it becomes carbon number 1, number 2, number 3, number 4, number 5, number 6. If I number it from the right side, it would be carbon number 1, number 2, number 3, number 4, number 5, number 6. So for the green one, you have one branch on the third position, another branch on the fourth position. For the blue one also, you have one branch in the third position and one branch in the fourth position. So from both sides, the location of the branch are the same. So which one I have to choose? In this case, when from the both side, the number which receives by each branch are exactly the same, you have to look at the alphabet priority. Okay? This branch is methyl, and this branch is ethyl. In this case, I number the parent from the side which ethyl receives the smaller number because it has alphabetic priority. So the correct system for the numbering in this case would be this blue one, because the ethyl would be in the third position and the methyl would be in the fourth position. The ethyl has the alphabet priority. So now let's name this one. I have to name the branch first. Between the methyl and ethyl, ethyl has priority and its location is on the third carbon. So I write 3-ethyl, and then I have this methyl on the fourth position. So I write 4-methyl. You can see that I write the hyphen between the number and the letter. So I determined the branches and their position. Now I have to write down the name of the parent. The parent with the 6 carbon is hexane. Okay, so we have done for this session, and this session is very important because the naming of the alkane is the base for the naming of the other hydrocarbons. If you don't know how to name the alkanes, it's very difficult to be able to name the alkene and alkyne. So work on the naming of the alkane for the next session. Okay, so before come to the class, make sure that you understand and you know how to name the alkane.